Well, one big one is, frankly, the movement towards virtual desktops. And it's an interesting one because if you look at it, virtual servers multiply machines by a factor of 10 to 20. When you get to virtual desktops, you're multiplying by the hundreds. So again, it exacerbates the problem of more eggs in one basket. It also is a much bigger opportunity because storage becomes, frankly, the biggest weight that prevents things like virtual desktops from taking off because the cost factor of storage is so inefficient behind those virtual desktops. The capabilities that we do with better utilization, very efficient, space-efficient snapshots, and more importantly, the ability to even look at, frankly, virtual machines or virtual desktops, not just as the storage data, but actually as images or as containers of these virtual machines, and how that goes into the future, we believe we will dramatically change the course of where things are going. It's funny, I still find a lot of people when they say, protect your storage, they're thinking about data, and it's an old concept. Today, storage is also your virtual machines. Your virtual machines are your application, and that is your business. So if you don't protect that, and you don't allow those applications to go forward, you've lost the ability to protect your investment. And really, as much as we love being in the infrastructure business and all of that, it's really about why are you in business, and the applications and how you keep those going into the future is key. It's even more crazy than that. What I find is that if you look at these vMotions or other motion capabilities, the virtual server layers and the hypervisors, they all make an assumption, and that is that they punt to storage to be this very nice shared storage that somehow you can just move stuff around. And it's sort of in the fine print that you got to realize that while you can do all these wonderful things at the hypervisor level, you really need to have pretty sophisticated storage below it. One of the things that DataCore has found is our ability to penetrate, especially at the small and mid-sized businesses where they can't afford to have these $100,000 plus storage arrays that can do things like automatic failover and failback. And that is really where you get into the ability to move things transparently. Because, if you have to actually shut the stuff down, write a script to be able to restart it somewhere else, you've just lost some business time. So, people pay a premium to have that non-disruptive business applications. And I think the promise of virtual servers and virtual desktops is hide those problems underneath from me. So, preventing these kind of disruptions is the key thing that DataCore does. One of the trade-offs is you get more capacity, but you usually get slower drives. The other side is if you go back in time, the way people solve a lot of the performance is you throw a lot more spindles, i.e. a lot more drives to try and spread the performance. The truth is, how do you overcome that? And there is no magic. I mean, one of the things we found very early is that as long as you've got mechanical rotational speeds, it's going to be slow. One of the beauties that DataCore does, and it's just part of our virtualization layer, is we have very sophisticated caching technology. And what we do is we take advantage of the industry trend, and that is that PC memories are pretty inexpensive. So instead of trying to solve the problem with hand grenades, do it simple. Just add some extra PC memory, put that memory into the servers, And what you've done is you've created a caching layer. And in effect, what you're doing is you're running those reads and writes out of memory speed. And therefore, what we typically see is we will typically increase speeds by a factor of 2 to 3x over those storage drives. So the bigger the capacity, I think the bigger the gap in performance, and our software helps to compensate for those performance bottlenecks better than anybody. There is no simple fixes on this. When you've got the potential for a failure, as you just said, you have to have two. Basic engineering hasn't changed from the old days, and the typical mode is that you've got this large drive in one particular storage array, and what you do is you mirror it to the other side in the same storage array. Well, you know, it's pretty obvious, and if you go through the literature, what you see is the fact that that mirrored copy is located even 10 feet away from that particular storage, you get an order of magnitude better data protection. If you can do it across the street, across the city, it's even better. So DataCore naturally allows this, what we call stretch high availability, and it's still at synchronous speed, so you don't lose the performance. That's really one of the most compelling and critical advantages we bring to the party.